Okay, so example 16 on page 190. And meanwhile, just allow me a couple of seconds so that I can start sharing screen. And if you have any questions, you can unmute yourself because it will be difficult to keep an eye on the chat screen. Excuse me. All right. So example 16 says, on an island that can support a population of 1,000 lizards, there is currently a population of 600. These lizards have a lot of offspring and not a lot of natural predators. So have a very high growth rate, around 150%. Okay. So we have, oops, sorry. We have capacity of 1,000. Currently, we have a 600, and it has a growth rate of 150%, a mammoth 150%. And the question says calculate the next couple generations. So what are we looking for? So again, the first job is to identify and match the data, given data set to our known ones. So let's do it step by step. What is this 1,000? What does this signify? What can we understand by this? Who wants to say this?
Is that the carrying capacity?
Exactly. You can see it says, the question says rather, the island can support a population of 1,000 lizards. It can support, so that means the environment can hold up to 1,000 lizards. That means 1,000 lizards can sustain there. And if you remember, this is actually our carrying capacity, K, right? Okay, what's next? So currently we have a population, I mean, the lizards population is 600. Now what's this? How can we denote this 600? What should be the notation?
P0.
Okay, so again, if Pn denotes the population at or after nth year, we know the initial population, that means the population we have started with, is P0. And definitely this 600 is the initial population we have. So we'll say it's P0. Okay. All right. Next. Again, you're fortunate enough that the question already has written it for you, that the growth rate is 150%. Even if it was not written, you can eyeball it and see that this is nothing but the growth rate, right? So clearly, this is our R, but we'll try to convert it to decimals. So this will be 1.5. If you remember, we always want this R to be in decimals. And if you're wondering how did you get to that, just go back to problem solving lectures and you will see we have seen this before. We have seen how to convert this percentage to decimals. We actually started our semester with this. Okay. If you still have doubts, Just let me know. Okay, now the question says calculate the next couple generations. So my question is, what are we looking for?
Are we just looking to see when the population will reach 1,000?
No, not quite. Anyone else?
We're just finding the population after a couple years, right?
Yeah, so I mean, what should be the notations? What's the notation we're looking for, rather? I mean, if I want to denote it with something, what it should be? Because I need to know what I'm looking for, right? What I need to find.
P2?
Almost there. Yeah, you're almost right. But not quite. What
Is
else?
it P1 and P2?
Very good. It is P1 and P2, right? Exactly. Because it says the next couple generations. It didn't say find the population on or after the second year. Just like the previous problem we solved. I guess when we solved try it now 5 or try it now 4, whatever it was. I guess try it now. Yeah, it was try it now 5. So it said predict the next 3 years population. That means we actually solved it for P1, P2, and P3, right? So understanding the question, again, is the first job you have in your hands. So we have the informations, we have the carrying capacity K, we have the initial population P naught, and of course we have the growth rate R. And from these given informations, we're trying to find P1 and P2. Okay, the next thing is to understand which which growth model fits the data set. Which model should we use? Any guess? Any guesses?
Logistic.
And why?
Because we're looking at a problem with a carrying capacity.
Very good. Yeah. Whenever the carrying capacity is given, you can actually, it's a naive approach though. You can actually see that it's kind of navigating us towards the logistic model. All right, so now we know that we want to use the logistic model, and the formula for the logistic model is this. Oops. Right? We know the formula. Now, the next thing is to plug in the values into their respective places. But this could be a tricky one. We need to plug in their values in their exact place, in their exact places. So now, the first population we'll try to find is P1. So that means on our left, we'll have P1. So if n is 1, how can we transform it and rewrite it? I mean, the right-hand side. How can we transform it? N is 1, right? So what should be this one? What's this?
600?
P2.
No, I mean, if you want to denote it with P, what's the notation? What should be the notation now?
P0?
P0, because we have n equals 1. So Pn minus 1 would be P1 minus 1, it's 0, right? So we can write, apologies, my Zoom is not, okay. So we can write P naught in place of all the Pn minus 1, right? Then we can actually plug in the values in their respective places. Okay, someone is in the waiting room. Just give me a second. All right. Next, let's plug in the values. And P naught is 600. We already know that. So let's plug in the value 600 plus R is 1.5. P naught again is 600. K is 1000. And P naught again is 600. So we have plugged in the values, possibly their exact places. But we can make a mistake here and there, or if we just somehow fail to convert the formula to its exact formation. All right, now we want to solve it. All right, let's do it step by step as well. What's 600 over 1000? I'm showing this step by step so that you can use these steps. If you can follow the steps and you get to the exact result you are looking for, your desired result. Okay, because using the calculator could be tricky, right? What's 600 over 1000?
0.6.
Sorry?
0.6.
0.6. Is there anyone who has a different result? So this is 0.6 coming from this. Just let me know if you have a different result, right? Because it's really important to use the calculator the right way. Okay. Then 1.5. So what's 1 minus 0.6? Now we are looking for this.
0.4.
0.4. So we have 1.5 times 0.4 times 600, right? Because it was already working as a product. You can see 1.5 times this item times 600. So I've actually rewritten that. Okay. Now, what's this product in yellow? What's 1.5 times 0.4 times 600?
360.
360. Again, if you have a different result, just let me know. We can cross-check your work and maybe we can find where did you got it wrong, where did you get it wrong, okay? And now, if we just add these two, we'll get 960. And this is nothing but P1. Any question on how did you reach that? No question at all? Very good. Okay, so now if we want to find P2, that means now N is 2, right? So what should be our corresponding formula from this?
It would be the same thing, but everywhere that you have P of 0, you're going to put 960.
Right. That means we'll plug in P1, right? Because we can see the formula says it's Pn minus 1 when you are calculating Pn. So if you're calculating P2, we'll have P1s in these places. And we can derive the value of P1 and plug it back here. Okay. Now, if we solve it using the same idea, it's 960 plus 1.5, 1 minus 960 over 1,000 times 960, we'll get 1,018. Okay. Now, here is an interesting fact. What was the carrying capacity of this environment, of this island rather?
1,000.
1,000. And that signifies that that island can actually hold up to 1,000 lizards, and it will still be living with harmony, and it will have enough resources. It will have enough oxygen. It will have enough food for their survival. That means they can still survive without any problems if the number of lizards is 1,000. But we have 1,018. Now, what's the first thing comes into your mind by just observing this? What could be the next case? That means if we try to find the population P3, what could it be? Should it increase more because we have a growth rate about 1.5? Should it increase more because we have seen, since we have a growth rate, we always have bigger values, right? Oops, sorry, not this way, this way. We always have bigger values as we progress. The population always grows, right? Even in the last problem, we have seen that. Let's see this one. The last time we calculated it. P naught was, where's the P naught? Okay, P naught was 20, P1 was 33, P2 was P2, okay, P3 was 85. That means we can see, we didn't really calculate P2. I guess we did say that, did say what it could be. Anyway, we can see the population is on the increase as we progress. But what happens with this? Should it increase? Should it stay like this? What should it be? Can you imagine anything?
It should decrease, right?
And why?
Because it's already above the max population.
Yeah, so let's just imagine it this way. If we have a glass full of water, if it's completely filled with water, if you pour more water into it, what happens?
It overflows.
It overflows, right? The glass cannot really contain even a single drop of water more than its capacity. It will definitely overflow, right? So in biological dynamical system, you can clearly imagine if we, let's say I have invited you guys for a smallish uh, party at my apartment, and I have only arranged party for, let's say, for 10 people, but somehow you have guests and I have 15 people to feed. What will happen? Some people will not have enough food, right? And they'll get angry and they'll leave my apartment, right? In a biological system, you can imagine if the capacity is 1,000 and somehow if it gets more than that, uh, this more amount will fight for the same resources, right? They will fight for the same food, for the same amount of oxygen which is available, which is on offer for them. And definitely it will not be enough. They'll fight it they'll fight for survival with each other. They'll fight with each other, right? And some will get perished due to the competition. Probably they will kill each other for the food. Probably they will die because, I mean, due to the lack of oxygen or food. But definitely, the population will get decreased, and somehow or other, it will go down, and obviously it will go below 1,000. Can we imagine this? Can you imagine this? Does it make sense, everyone?
Yeah, it makes sense to me.
Is there anyone who is kind of confused what's happening here? And you can actually mathematically calculate it as well. Let's see what happens with P3. If we calculate P3, this will be P2 plus R times 1 minus P2, oops, sorry, P2 over K times P2. If we plug in the values, P2 was 1018, 1.5, 1 minus 1018 over 1,000 times 1018. Now, if we calculate it using the same idea we have used before, we'll see that this will be 991, and it's definitely less than 1,000. Even if we couldn't understand what will happen, I mean, if we somehow don't understand what's the main idea of a carrying capacity, we can actually calculate it mathematically and see that. Right? And it will happen each time the population gets more than the carrying capacity. The following year, it will definitely get decreased and come down to its capacity. It will definitely be less than the carrying capacity. Okay? Any questions? Anyone, any question? I'm sorry, I'm late. Okay, no problem. All good? Let's move on then. Now, let's quickly look at example 17. And this will be the last content of this topic, growth models. As I said, on Friday we'll have an exam review session, and on Monday you'll have your third exam. And I guess from Tuesday we have the spring break, so we can enjoy a bit of vacation. I guess it's 5 days of vacation, so that's a good thing. Anyway, let's move on to example 17. And example 17 says we have the same island and okay, no, on a neighboring island. Okay, so it's not the same island, but yeah, it's on the neighboring island. And this time our growth rate is 205%. It's even higher than the previous one. Previously we had 150%, right? On example 16. Now we have a 205%. And they haven't really solved it for us, but they actually have shown us the graph and kind of gave us the idea of what happens if the growth rate is significantly higher. If we have a bigger growth rate, what happens to the population? They have just given us the hint. They haven't really gone deep into that, but they have shown what happens. So let's just see. So if we have a growth rate of 205%, we want to see what happens. So if we calculate the population P1, so P naught times plus R times 1 minus P naught over K times P naught, and the initial population is again 600. Only the growth rate has changed, which is 2.05, right? One minus 600 over 1000 times 600. Can you calculate it for me? I'll cross-check your work. What's the population? Solve it up to P4 and let me know once you're done. What's P1, P2, P3, and P4? You have the data set. P naught is 600, K is 1000, and R is 2.05. What's your P naught, or rather P1, P2, P3, and P4? Do it one by one. If you're done with P1, let me know. Use the same idea we have used for solving this. Use the same steps. Just we have a different growth rate now. I'll take answers from 4 different persons. And if it matches, then we can proceed to the next one. So for P1, we already have one answer. I'll take 3 more to cross-check. So one of the answers is 1092. Is there anyone who has a different result for P1? Okay, I have one more 1092, so looks like this is the right answer. Let's just take one more for P1 and cross-check it. Is there anyone who has a different result? It's a really good time to see yourself, to see where are you standing at this moment. If you can calculate it, then you are on the right track. So please cross-check your work and match it with others. This is the right moment. Okay, so we have 41092. Yeah, we can move on then. What's P2 now? I already have one P2, which is 886. Let's just wait for others and cross-check it. $886 again, okay. Is there anyone who is struggling to get to this result, who is struggling to find this, calculate it? Is there anyone? Just let me know. If you have any hesitations and you don't want to talk here, just email me, okay? And we can chat. We can chat via email or even via Zoom. If schedule that works both for us, we can meet via Zoom. Just let me know, okay? Okay, anyone else for P2? Anyone has a different result than 886? Take your time and solve it because we are already at the end of the semester. Okay, I got 1271. Okay, so we have a different result, 1271. And we'll try to cross-check your work, okay? No worries. Even if it's wrong, no worries. As long as you're trying, we can actually make corrections if there is any, okay? Anyone else has a different result or doesn't agree on the values, on these values rather? I have 4 different people and 2 different results. So I'll take 1 or 2 more for P2. Okay, I got 1696.05. It can't be a fraction. Did you get it? Did you get 1696 for P2? Okay, it can't be a fraction. So if you round it to the next whole number, or rather the nearest whole number, it should be a 16. It should be 1696, right? You have to have a whole number. It's a population. It can't be a fraction. Okay, interesting. We have another different result, which is 1098. You can see that's the reason I am saying over and over again that practice more of these problems and cross-check your work. If you have this solution, just match your result. If you don't have a solution, discuss it with your friend or send it to me and cross-check your work. It's really, really important. You can see you have 4 different results, and ironically, only one of these is right. And the funny part is, even if I haven't calculated it, I actually know the answer. I can eyeball the data set and say which one is right. Okay, so let me give you a chance. Who wants to volunteer this answer? How can I eyeball this data set and understand which one out of these 4 is right, even if I don't calculate? Is there any hint? Is there any way I can do that? Anyone?
Is it the one that is less than 1,000 because that's the maximum?
Sorry?
Would it be the one that is less than 1,000
And why?
because 1,000 is the maximum?
Exactly. Exactly. Very good. I know the carrying capacity is 1,000. I already know that, right? So if the population after first year is more than 1,000, I know in the second year it will definitely go down and it will go below 1,000. I'm pretty sure, even though I haven't calculated it. I just can't. I can just eyeball the data set and clearly understand that I'm not sure whether it will be 886 or not, but I'm pretty sure that it will be less than 1,000. Can you see? Does it make sense, everyone? Now, let's just show how can we get 886, because I can see you have a different result, and that's okay. As I said, you don't need to get demoralized. So for P2, okay, so those who has a different result, what's the formula for P2? What it should be? Obviously, we'll have R times something. What should be the notation in place of the blanks, bluish blanks?
1092.
Sorry,
Oh, do you want the number or do you want?
I want the notation first in the blue spaces.
P1?
P1, exactly. Because we are calculating P2, it has to be P1, right? And now we can plug in the values. So it should be 1,092. R is 2.05. 1 minus 1,092 over 1,000 times 1,092. And now, first find what's the value if we divide 1,090 over 92 rather over 1,000. If we divide 1,092 by 1,000, what's the value? Those who had these three values, you can answer now. What's 1,092 over 1,000?
1.092.
1.092. Okay. And now, what's the value if we subtract it from 1?
0.092.
No,
Negative 0.092.
negative 0.092, exactly. I guess that's where you got it wrong. It's negative, right? You're subtracting it from 1. 1 minus 1.092. So it's negative 0.092. Right? And now if we multiply it, 1,092, and we have a negative in this product, so we know if we multiply a positive with a negative, the final output is negative. We know that. For your convenience, let me write it for you. If you have both the product of, or rather both the values of the same sign, you will have a plus as the final sign. If you have the alternating one, that means a plus and a minus, then the final sign would be a negative. We have a plus here, and a negative here. So that means we have the alternating situation. So the final sign would be a negative, right? Now, what's the product of these three? Those who got this wrong, it's your chance to make these things clear.
Negative 205.95. I think.
20, 2.95.
0.95.
Let me cross check this. 2.05 times 0.092 times 1092. I guess it should be 205.95. Did you actually say that? Maybe I didn't hear it right. Is there anyone who has a different result? So if you subtract it, we'll get 1092 minus 205.95. We'll have 886.05. And since it's a population, we can't have fractions. If we round it to the nearest whole number, since it's less than half, we can say it's 886. Is there anyone who still has doubts? I'm more than happy to rediscuss it. Anyone else? Okay, what's P3 and P4? Real quick. What's P3? Using the same data set. P3 is 1093. Okay. If you have a different result, let me know. And what's P4? 885. Okay, 885. If you have a different result, just let me know. So now if I have the values, P1 is, let me show it this way. So for P1, we have 1092. For P2, we have 886. For P3, we have 1093. And for P4, we have 885. Can you see it's actually following a pattern? This pattern is kind of symmetric. You know, we can see there is a certain rule it's following, or it's kind of changing using a same pattern, right? Same change of behavior. And each time it gets more than 1,000, you can see it's definitely getting going below 1,000 the next time. So if you graph it, it looks like this. So you can see there is a cycle here. Although it's not exactly the same as this, it's not exactly the same as this, but it's quite same, right? It's quite similar. You can say it's almost the same. So it's maintaining a cycle. So whenever the growth rate is higher, we get to see these things. And when it's really, really, really high, we have chaos in the dynamical system. Chaos means, in short, irregularity. That means no regular changes. There will be different patterns. It will change with irregular uh, behavioral impact on each other. We'll not go deep into that. The book didn't go deep into that either. But we're just trying to show that it happens when the growth rate is really, really high. Okay, it's just the idea. You don't need to get panicked about it. Okay, you'll not be asked to show anything like this. Okay, we have successfully finished the growth models. We still have one more day when we will chat about this more. So start practicing the problems from the exercise spatially, and let me know if you have any problem. Okay. Okay, let's see you guys on Friday.